All right, question 16. A and B are 2 points which are 10 meters apart on the same horizontal plane. A particle P starts to move from rest at A, so it's stationary, directly towards B with constant acceleration of 0.5 meters per second squared. Another particle Q is moving towards A with a constant speed of 0.75 meters per second and passes through B at the instant that P starts to move. So they both leave the points A and B at the same time. At some time t after this, particles B and Q collide. Find the value of the time and the speed of P immediately before the collision. Diagrams are king. We have a point A and we have a point B, and they're 10 meters apart. A particle P, let's get the particle P. It's initially at rest, so what we know about P is a few things. We know it starts at 0, the velocity starts at 0, and it has a constant acceleration of 0.5 meters per second squared. Particle Q at the same time, which means we'll make that time 0. Time 0, it's at B, and it's already traveling. It has a velocity, and its velocity is constant of 0.75 meters. So if we start assigning directions, we can say a positive direction is A to B, which would mean it's a negative velocity if we want to work that way. All right, those two particles are going to collide somewhere. Where is that collision? How long does it take to get there? Right, so we're going to make point A our displacement of 0. And of course, we're dealing with displacement time. For particle P, we want a formula that uses S, T, U, and A. And that formula is S is UT plus a half AT squared. Okay, that's great. That's going to give us the position of particle P. So let's put in what we know. The initial velocity is 0 and the acceleration is a half. So we're going to get its position, or its displacement. It's going to be a half of a half, which is a quarter of t squared. Half of half, quarter t squared. Perfect. So at some time, that's where it is. And of course, these two things are going to hit each other when the time is the same and when the displacement is the same. For our other particle B, it's constant velocity. So we're doing velocity is the distance on time, or the distance is velocity multiplied by time. Let's do that one. Distance is velocity multiplied by time. Okay. What we know is it actually is starting at a displacement of 10 meters, and it's moving in the negative direction. All right, so our displacement for B is going to equal, let's start at 10, and the velocity is negative, so we're adding a negative velocity anyway, minus 0.75 t, and of course t is just time. Right, so we have two equations, both are displacement, and these particles are going to collide and are in the same position. So we equate those two together. A quarter t squared is equal to 10 minus 0.75, which is 3/4 of t. Right, so we can get rid of these fractions by multiplying both sides of that equation by 4. And we would get t squared on this side when we multiply by 4. On the other side, we're going to get 40 minus 3/4 times 4 is just 3. Let's rearrange at the same time. So we've got minus 3t, we take it over, we get plus 3t, and we've got plus 40, so we take it over and we get minus 40 equals 0. So we're just making a quadratic again that we can solve. What multiplies to negative 40 has a difference of 3, 5 and 8. So we have t plus 8, and then t minus 5 is 0, which gives us a time of negative 8. We're going to reject that, or a time of 5 seconds. Okay, that's when they collide at 5 seconds. For part 2, we need to find the final velocity of particle P. All right, so we know everything we need to know to do this. For part 2, we know the initial velocity is 0. We know the acceleration is 0.5. We know the time is 5. That's just when it hits the other particle, so it's going to be the maximum speed that it reaches. And we're trying to find the final velocity, it's question mark. What do we use? V is equal to U plus AT. And that's 0 plus 0.5 times 5. And that ends up being 2.5 meters per second. I think we're finished.